This is very scary and crazy in the same time. Please use this only for educational interest, only for educational purpose. No black hat activity is allowed. So with that being said, watch this. Now if we inspect the loader, inside the last section there is our DLL. Remember, our DLL has inside the function that inject itself further. So when I double click on this loader, it's deleted itself. Before it deleted itself, it called run.dll32.exe to execute the DLL that the loader has been exported to AppData. And now the DLL is running inside run.dll32.exe, and from there it will inject by itself inside notepad.exe. When I click OK, you can see here down it's a notepad icon appeared. When I click it, it says from fun.dll I am inside C Windows WoW 64 notepad.exe. So if I cannot close it because there is a while true loop as I told you, but right now our DLL is inside notepad.exe. We can use it, we can verify that with Process Hacker or Process Explorer. I'm just gonna put this away. So we go here, we can see there is a notepad process. We can even right click on it and open file location, and we can see that this is a valid notepad process being ran from the 32-bit version of the pad, and it is actually our code, so it's our DLL. If you want to find our DLL inside the notepad, you just right click on the notepad process, we go to properties, and on the memory tab we just search the RVX protection. This is read write execute. You remember we use that a lot. So I don't think it's this one, this is just 4 kilobytes in size. So there is another RVX with 304 kilobytes. So we go on this little arrow, we double click here, and as you can see, this is our DLL. It starts with MZ. So this is our legitimate DLL. Our DLL now hides inside Notepad at this base address. You can try and verify if this is the legitimate DLL that we were coding by just saving this part of the memory on a desktop as an .dll file. Okay, and then you can just right click and view it with CFF Explorer. That indeed is the right. If I right click on the notepad and terminate, it will close our program. So we didn't just created a process and renamed it to notepad and we run our code. This is actually the exact legitimate process of notepad, and our DLL executes inside like an executable using machine code. Hi guys, and welcome to the 5th video tutorial. We will learn how to let DLL to inject itself inside another process like notepad.exe. For that, as you can see, we have here the DLL main, which will be called when the DLL will be initialized, and this exported function, which will be triggered by run.dll32 to actually run this DLL. But in our case, we need to create a second exported function so we can know when this DLL main function has been initialized. Note, we don't need that when we run the DLL with run.dll32, but we need that when our DLL will inject itself inside another process. Okay, so let's get started. I'm gonna just write the second function. So it's gonna be an extern C, exactly like this one. I don't think we need to make it as a in, we can just leave it as a void. I'm just gonna call it main entry. We will need to have here a global value was DLL main called, and we're just gonna set it to false. So here, if DLL main was called, so if this is equal with true, I'm just gonna write an infinite loop so we can know better what's happening. So while true, we're just gonna copy paste this code from the fun entry. Else, if the DLL main wasn't called, we're just gonna write here a message box. As I told you, when we are using the runDLL32 as a run key, this function is irrelevant. But since the injection code will be inside the DLL, we're gonna create here another CPP file. We need this so we can understand when DLL main will be called. We're gonna initialize this value once the DLL main will be called. So before switching on the callback, I'm just gonna write here true. And also I'm just gonna write this now and we're gonna use it later. I'm gonna tell you why. When DLL will inject itself and it will call DLL main function, we need to initialize this value, the first parameter from DLL main, which will be the image base. So I'm just gonna write here a dword type DLL param, let's say, and then this DLL param, before we setting that DLL main was called, we're just gonna initialize it, dword. We're just gonna set it equal with the first parameter from DLL main, which is base, but we're gonna typecast it as a dword. Because once the DLL will inject itself, it needs to know its current image base. That's why we're gonna move this fun entry function above the DLL main, like that. And I'm just gonna rewrite this code. So we don't need it like that. I'm gonna make it as a void. We don't need to return anything. And here DLL needs to know its current image base. So we're gonna do it as follows. We're gonna declare a variable. We need to know where is our DLL path. Then inside the dword, we're just gonna keep this the value from getModules file name, and I'm gonna tell you what we're gonna put here. Here will be the DLL path, and here will be the size of max path. So here, as I told you, we need this DLL param, but we need to typecast it as an H instance. So we're gonna leave it like that. Then we need to show a message box. So I'm just gonna write char test as a 1024 size. Then we're gonna use vsprintfa to put inside this char another string of this DLL path. Once that's finished, we're just gonna show a message box with this test value. We don't need a caption, and that's it. And here we're gonna inject DLL inside remove process. So here we're gonna call a function that we're gonna write in a second. Okay, so the logic should be clear for now. I'm just gonna write here true because this is a bool, and I'm just gonna get rid of this default. So we're just gonna leave DLL main like that. Okay, let's create a header file. Let's call it like in the other project, tools. Tools.h. So we're gonna include here windows.h. We're gonna leave pragma once, and we create here a namespace with the name tools, and we're gonna create here the function definition of our inject function. It's gonna be an int type. I'm just gonna call auto inject. It will take an LPSTR of target process and LPC STR is gonna be our payload. So our payload is the DLL path. Okay, so our function will look like this. I'm just gonna copy this. Now we're gonna create another source file, add new item, cpp tools.cpp, and here we're gonna start making our function. I'm just gonna include here include tools.h. So we're gonna start by creating a process in a suspended state. Then we will use a function from ntdll.dll to zero out the current PE image from inside the remote process. Then we're gonna copy all the sections from DLL path. Then we're gonna do some relocations, and then we're gonna use machine code to call DLL main within inside the remote process. So we need two structures: LP startup info A, startup info. Just gonna write as new startup info. Then LP process information, the same as above. New startup info, sorry, not LP, and here new process information. Okay, now we also need a process basic information structure. But notice we don't have it yet, so we need to include it. We're gonna use include internal. I'm just gonna make it as a pointer. So process basic information. I'm just gonna name these variables with underlines so it can be much more readable. New process basic information. We're gonna use create process A, and we're gonna store it in a bool value. And the parameters are as follows. Null. Here will be our target process. Then null true. The flag, the DV creation flag, which is create suspended. Then just put this aside. Now we need the LP environment, which can be null. The current directory, we can leave it null. And here are the two structures, startup info and process information. Not process basic information, the process information, like that. Since we store it in a bool value, we're just gonna check if this is true. So if created equals to true, we're gonna get a handle to this process. So handle target process. Let's just call this target. I'm gonna type target, and this will be actually the target process. So this will be just the path to our process and the path to our DLL. And in order to create this process in a suspended state or in whatever state we want, we need to enter here the path. So this is just a target path. Now we create a value with the name target process because we need the handle of this process from process information structure. So process information, we need the age process. Okay, and we need to make sure if this target process is not equal with invalid handle value, then we can proceed further. Since we have now the target process handle, we need to use a function from ntdll.dll to get out the image base of this process. So we're gonna use ntQuery information process. First is a process handle, so target process. Now we need a process information type class, which is just process basic information. Then we need the process information as a pvoid, which is our process basic information variable. Then we need process information length, which is the size of process basic information structure. Basic information structure. And then we're just gonna difference inside this return length value, which we didn't create it yet, so I'm just gonna create it here. Just gonna make it 0, and here we just difference it. Return length. And we have the value inside this process basic information structure. We fill the structure. Now we need to get the offset of the image base from the target process. So we're gonna store it in a dword image base offset. It's gonna be equal to process basic information. We need this PEB base address plus 8, since the image base is 8 bytes away, and we need to typecast this as a dword. Here is dword. Okay. Now we need to read the process memory, and we need to store the value inside an LP void. So LP void, this will be the destination image base. I'm just gonna make it equal with 0. We're just gonna declare here a size t value type, so we can store how many bytes were read. Equals with null. And now we're just gonna read the process memory. We're gonna store it in a bool value. So we're gonna read the process memory. The first parameter will be the target process. The second parameter will be the address, which is the image base offset. Where is the image base exactly? And we're gonna typecast it as an LPC void. Then the next one will be the destination image base. We're gonna just difference here the value. And then we're just gonna read 4 bytes and difference everything inside bytes read. Like this. If the memory from the process has been successfully read and this destination image base value is not equal with error, we're gonna proceed further. If process read it's equal with true and destination image base is not equal with error, we're gonna read here the DLL. A similar code as in the ethical injector project. Handle DLL file, create file A. Here will be the DLL file, not the DLL file, I think we called it payload. So the second parameter, generic read null open always. and null and null. We don't care too much about the other parameters. And if this DLL file it's not equal with invalid handle value, we're gonna get the file size and store it in a dword. File size of this DLL file, and here is null. We're gonna store in an LPD word the variable, the file bytes that were read. LPD I'm just gonna make it equal with 0 for now. And here will be the DLL buffer stored in an LP void. We're gonna use heap alloc instead of local alloc. Get process heap. And here will be heap 0 memory and DLL size. Here is equal. Okay, if this buffer is not equal with 0, with error, now we need to go inside this DLL file and get the image DOS header, anti headers, and so on. P-image DOS header, DLL image DOS header gonna be equal with this DLL buffer. However, we need to typecast it as p-image DOS header. Okay, then we need the p-image anti-headers. DLL image anti-headers equal, we need to typecast. So the anti-headers are inside the ELFA new, but we need to add to this ELFA new also the DLL buffer from above. So it's DLL buffer plus DLL image DOS header ELFA new. However, we need to typecast this DLL buffer to a dword. Okay, so it will look like this. We also need a DLL image size. I'm gonna store it inside a size D variable, and it can be found inside optional header. So size T DLL image size should be equal to DLL image anti header headers optional header size of image. Okay, now we have all the information we need from this DLL and also some information from the target process. Now we need to use a function from within inside ntdll.dll to actually destroy the PE image from the target process, so it can zero out everything and our DLL to fit inside. So to do that, we need to use a function called nt-unmap-view-of-section. I'm just gonna write it here, nt-unmap-view-of-section. I'm just gonna name it unmap section, and I am gonna include it at runtime. So we're just gonna define it here as using nt-unmap-view-of-section equal to anti-status win API, and here we require two parameters, handle type and a pvoid type, like that. So now we're gonna use getProcAddress to get the address in memory from ntdll of this unmap-view-of-section function. So getProcAddress So we cannot just type anti-DLL and then here anti-unmap view of section, also inside quotation marks. We cannot do it just like that. We need to get the module handle out from anti-DLL string. So get module handle A, just like that. And we need to typecast everything as anti-unmap view of section, like this. So it will look like this. Now we need to check if this function has succeeded into destroying the image base of our target process. We're just gonna use an if statement and we're gonna check with anti-success. So we're gonna call this function by just adding the target process and our destination image base declared unmap section, and here we're just gonna enter target process and destination image base. We need a new destination image base, so new destination image base. We're just gonna use virtual alloc ex, so virtual alloc ex. So the first parameter will be the target process. The second parameter needs to be an address, so the address will be the destination image base because we used anti-unmap view of section to zero out everything from there. So now we can use this part of the process. Then here we'll need the DLL image size. The allocation type will be the standard one, mem commit, then mem reserve, and then we just need the protection type page execute read write. So it should look like this. Now we just need to equal the destination image base with the new destination image base. We need to calculate a delta, so dword delta image base will be equal to destination image base minus from DLL image anti headers. We just need from optional header the image base. So it's just the difference between these two. And the first one we need to typecast it as dword. We don't forget about that. Since the destination image base now is equal with the new destination image base, we just need to set this also inside the DLL. So DLL image anti headers, optional header, this image base will be equal to destination image base, also typecasted to dword. And then we're gonna write this new image base to the target process. So here we need the target process, then the new destination image base, the DLL buffer, if you remember, once we read the DLL, and the size will be the size of headers of our DLL. So DLL image anti headers, optional header, size of headers, and the last parameter can be just null. Once we have wrote the new destination image base inside our target process from our DLL, we need to copy over all the sections from our DLL inside the target process. We're gonna use a for loop. Before that, we just need to declare two variables. So this will be DLL image section header we're just gonna typecast it to this one. And here to get a section header, we just need to get inside DLL buffer plus the DLL image DOS header. We need the ELFA new plus the size of the image NT headers 32, because we use everything in 32 bits right now. So image NT headers 32, as you can see. Okay, but don't forget the DLL buffer to typecast it as a D word. We need to store the first value inside another variable as old. So we're just gonna create a second variable type image section header. Let's just write this DLL image section header old, or rather old DLL image section header. This will be just equal with DLL image section header. The for loop will look like this: for int e equals to 0 until e is less than the DLL image NT headers file header and here is number of sections e plus plus. Here is semicolon. Okay, so the number of sections can be found inside the file header of the NT headers from the DLL. Now we need to get the destination section location. So p void destination section location, which will be equal to destination image base, what we declared up, then DLL image section header, and we're gonna get out from this one the virtual address. Don't forget the semicolon. And we also need to typecast this as a D word. Okay, something is wrong. Unsigned long to p void. Okay, we're gonna typecast everything as a p void. Like that. So now should look like this. Actually, here we just need one. Now we need the source section location, where to copy from. This is where to copy to, and now we need the where to copy from part. So p void source section location will be equal with our DLL buffer plus, so the value is pointer to raw data from this DLL image section header, pointer to raw data. Don't forget here to add our D word typecast, and like above, everything typecasted as a p void. Now that we know where to copy to and where to copy from, we just need to write this to the process memory. So write process memory. Note, if we have used our current process like we were doing inside the loader, we didn't need to use write process memory. We could have used just mem copy. But since we are talking about another process, we just need to use the write process memory function. So target process, destination section location, this is the where to, then where from will be the buffer. So here will be the size of raw data of our DLL image section header, size of raw data, and the last one can be null. Once we have wrote inside the process memory this source section location, we're just gonna increment the source image section value, which is this one, the first. So after we have copied successfully all the sections from our DLL inside the target process, we just need to relocate these sections, because inside the target process these sections might be located in a very weird way, and our process will be corrupted. Image data directory relocation table. It can be found inside the anti-headers, of course in optional headers. So DLL image anti-headers, optional headers, data directory. Here is the 5th index. Or if you want, we can just type the whole name. So I believe it's image directory entry base reloc. Yeah, this one. So if we hover over it, is okay, it is index 5. We're gonna make DLL image section header equal to old DLL image section header. Here we're gonna start a for loop to relocate everything. So for, again, let's just put, I don't know, x equals to 0, x less than DLL image anti-headers. We get out from file header the number of sections, x plus plus. So here we need to find the reloc section. So I'm just gonna open this DLL. Inside the section headers, we need to get this reloc section right now. We need to make sure that we have found reloc section. First, we need to declare this reloc section as a byte pointer. So we're just gonna call this reloc section name, which will be this dot reloc that I've showed you, but we need to typecast it as a byte pointer. Then we're just gonna use the mem compare function. So if mem compare and it's not equal to 0, so if we didn't find it, then we're just gonna continue until we find this reloc section. So this DLL image section header, we're gonna increment it, and here we're just gonna continue this DLL image section header. So we get out here the name, we compare it to this, and here we type 5. Yeah, once we have found the right section, we stay inside the for loop. We just get out of this if statement. We declare a dword type source relocation table. We need the raw data out of it, which will be the DLL image section header pointer to raw data, and also a dword of relocation offset 0. Okay, now let's do the relocation. So while the relocation offset is less than the relocation table size, so we'll use a structure called p-base relocation block, and we're gonna just declare it here. So before the function, just copy paste the base relocation block, and we also need the base relocation entry structure. We just declare a p-base relocation block type variable. Just gonna write that relocation block equal with the following. Just gonna typecast it to this structure name. Will be the DLL buffer plus the relocation table row plus the relocation offset, and we need to typecast it as a dword, the first param, the DLL buffer, as we did before. Then we're just gonna increment the relocation offset with the size of this p-base relocation block without p, so we don't need a pointer type. Now to count how many relocations we have, we need to get out from the relocation block the block size, and we need to subtract from it the size of this base relocation block, and we need to divide everything to the size of a base relocation entry, so the second structure. Dword relocation entries is just gonna be equal to the relocation block. We get out the block size from it and subtract the size of the base relocation block structure. Base relocation block structure, exactly like above. And now we're just gonna put this inside parentheses, and we're gonna divide it to the size of the second structure we declared, base relocation entry. So relocation entries, let's just call this relocation counts. So this will be equal, we need to typecast it to pbase relocation entry, same thing as the relocation block value. So we just need to get this out. And unfortunately here we need to do another for loop, so we can actually write in the end to the target process the relocated addresses of these sections that we are relocating. So we declare here a dword type variable, not an integer. So dword, let's say a equals to 0 to the relocation counts a++. We're just gonna increment here relocation offset again, but with the size of the base relocation entry, so the second structure that we declared up. If from the relocation entries at index a the type is equal to 0, we're just gonna continue until the type is not 0. After that, we get out from this if statement. Now we create a patched address and we read from process at this address location, and then we're gonna write the right patched address to the process. Dword patched address, we get out the page address, and it's gonna be plus the relocation entries a. We need the offset, where is it starting from. We need a patched buffer because we need to read from the process at this address and store what we find inside a buffer. The buffer will be a type of dword, so patched buffer is going to write it to be equal to 0. Read process memory. We need to read at this location. So in order to do that, we write target process destination image base plus the third parameter will be the patched buffer. We difference that. The n size will be the size of a dword. And the last one we can just store it here inside another dword bytes thread, which will be equal to 0, and we will difference that value here. Okay. First, we need to typecast it as a dword and everything as an LPC void, as you can see. It requires that. Once we have read from the process at this location, we need to increment the patched buffer with that delta, with that difference between the old image base and the new image base. So delta image base, I believe we called it. We write the new address to the target process. We write process memory target process here. We're gonna do exactly like here, but it's not an LPC void, it's gonna be just a p void type. Okay, the next parameter will be the buffer, which is the patched buffer, exactly like there. So we difference the patched buffer. Here will be the size of the word, and here the bytes read from the file, which is, I believe, here file bytes read. We don't difference that. Now we have successfully relocated all the sections from the DLL that has been copied inside the target process. This is the for loop and the while loop. We get out from everything, and now comes some important part. Let's just talk a bit about an executable. If you would have had an executable and we wanted to call, for example, notepad.exe and tell to this executable that we are coding right now that when once it's inside the notepad.exe to actually run itself, that would be very easy. We just needed to create a context. We need to make the EAX register for 32-bit and RAX register for 64-bit equal to the address point of this executable. But since we have a DLL, we can't just inject our DLL inside notepad.exe, and once we add some values inside the EAX register to expect to execute. It's not gonna do that. That's like simulating the double click on the DLL. It's not gonna run. That's why we will use machine code. We cannot use assembly because this is not like the loader. In the loader project, we already done that. We need the DLL to inject itself inside another process. Before we do that, we're just gonna create here the context variable. That's gonna be an LP context new context. We're just gonna make the context flags as context integer for 32-bit. So we need the context flags as context integer. Once we did that, we need to get the thread context from our target process and set it equal to our context. So we're gonna use a function called getThreadContext, and our target thread will be inside the process information structure. So process information h thread, and here the context, the LP context, which is what we declared. Play a bit with the context, and then we're just gonna set the thread context back to the process. So set thread context, which is the second function similar to the get thread context, but here we're gonna set it using these two parameters. So the h thread from the process information structure and the context. And then don't forget something that's very important, to resume the thread. So resume thread, and the thread will be this one. Return here 0. Don't forget to close the handlers. I believe we have two handlers, the DLL file and the target process. The DLL file is here. We're just gonna close it here. Close handle, DLL file, and the target process is here. Close handle, target process. So let's say our target process is notepad.exe, as I mentioned before. After we have successfully copied every section from the DLL inside notepad.exe and we have successfully relocated all the sections, now we need to create a context. We need to get the thread context out from this process. As I mentioned before, if we wanted to do this with an executable file, inject an exe inside notepad and run it, we just need to create a patched entry point. So since we use the function nt-unmap view of section and the image base from the notepad.exe now is gone, we injected all the code from an exe inside notepad.exe. Now we need to get the address of the new entry point and add it to the EAX register. EAX is for 32-bit and ArrayX is for 64-bit. So for an executable, we just gonna declare here a patched entry point, which will be equal to the destination image base plus the DLL image anti-headers we get out from these anti-headers. Of course, in optional header, we have here an address of entry point. And don't forget to typecast this as a D word. Once we get the new entry point of our executable from within inside the notepad.exe, we can just say context EAX is gonna be equal to this patched entry point, because EAX requires a D word. Okay, so like this the code would work. Is almost like simulating a double click on our executable inside notepad.exe. But as I mentioned, we cannot use here this code for our DLL because our DLL will never run. Remember, when we use run dll32.exe to run our DLL, we call our exported function. We call first the fun entry. When we call it, the first function that will be executed will be the DLL main, and DLL parent will be equal to this image base from our DLL, from within inside the DLL, and also this value will be equal to true. Once this value is equal to true, it will be called the second exported function and do some while loop. That's why we cannot do this here. This will work for executable, but we cannot use it with a DLL. So here we need to use machine code, which is equivalent to opcodes. In order to do that, we need to create some kind of a template. So I'm just gonna write here code for executing DLL main function when the DLL is inside the target process. So as I told you, this code shouldn't be necessary when we run the DLL with run DLL32, but when the DLL will execute itself inside the target process after it injects itself, then it needs to call this DLL main with all three parameters. So I am just going to copy paste this here. So we're gonna store everything inside a pipe array. I'm just gonna call it code. I'm just gonna make it equal and leave it like that. So this is a very interesting topic, and to finish this code we just gonna continue it in the 6th video tutorial. Thanks for watching and don't forget to like this video. Bye.